the new Peopoly Magneto X 3D printer, hot off the production line. I'm excited to show you one of the first production units of Peopoly's Magneto X 3D printer that I just received as part of their first production of shipments to fulfill their pre-orders to customers. Hi, I'm Ken of Rist Innovations, and I just want to mention that I paid for my Magneto X with my own money. I have a lot to cover, so I have broken my video down into the following sections, and you can find a table of contents with hyperlinks in the description below if you want to skip around the video. There aren't many videos out there yet that show a lot of making of parts on the Magneto X, so I have a large section on making parts. But I also have a step-by-step guide on how to get the printer up and running, and I also show how I installed one of the first installation upgrade kits, so you don't want to miss that as well. So let's get started. The first time I saw the Magneto X in person was at last year's Earth show during the September 2023. I was able to interview Peopoly's CEO, Mark Peng, and so if you're interested in that interview, the link is in the description below. Number 1, features. The Magneto X is the world's first desktop 3D printer with a magnetic-based linear motor system, so no belts and pulleys. Peopoly claims a repeatability of 3 microns, a maximum printer speed of 800 millimeters per second, and a maximum acceleration of 33,000 millimeters per second squared. The Magneto has a print volume of 400 by 300 by 300 millimeters. The linear motors for the X and Y direction offer true closed-loop controls. The extruded design offers 3 sizes, short, medium, and long, with the long melt zone nozzle offering a peak flow rate of 60 cubic millimeters per second. It uses a E3D V6 volcano-style nozzle in 0.4 and 0.6 millimeter diameters, and a custom cooling system and a maximum hot end of 300 degrees C. It uses a load cell sensor for auto-leveling. The Magneto X has 4 independent Z-axis stepper motors to level the build plate. The build plate has a 1000-watt AC heater that quickly heats up the build plate to a maximum of 130 degrees C. It uses a flexible PEI plate with a texture on one side and this pattern on the other side. The Magneto X uses Clipper firmware, and Peopoly sponsors the Clipper project. Currently, Peopoly offers Wi-Fi connectivity, however, they will have other options in the future. It also has a built-in camera and a large 7-inch color touchscreen. They use a custom version of Orca Slicer, and soon the standard version of Orca Slicer will have the Magneto X as one of the printers to choose from. Peopoly also offers an optional acrylic enclosure to allow you to print higher temperature materials such as ABS, ASA, nylon, PC, etc. They are working on an optional heated chamber module for even more temperature stability inside the printer for higher temperature materials. When they launched the product last September of 2023, the pre-order price was $1,399, which they sold out within a week. They have had a few delays, so now they are just starting to ship their first production orders during early March of 2024. Once they finish their pre-order shipments, they will be taking additional orders at the full price of $1,999. Section 2. Preparation and unboxing. Peopoly shipped the Magneto X on a pallet to better protect it because they were seeing shipping damage when they were shipping the beta units to their beta testers. However, for my production unit, FedEx removed the pallet and it just showed up in this box. The printer is very heavy, like 30 kilograms. Time to unbox my Peopoly Magneto X. Quick start guide. I asked for my friend Franz to help me get the printer out of the box and down the stairs to my workshop.
I'm Hans. I'm Franz. And we are here to lift you up. Yeah. Franz, you look really buff. Have you been working out? No, it's all natural, you know. Franz, yeah, I would like your help to lift up my Peopoly Magneto eggs. That sounds really heavy, but I think I can do it. Let's do it. Yeah. Oh, yeah. Okay, here we go. 1, 2, 3. Yeah. Oh, yeah. I'm kidding. Wow. That's amazing. Good job. Oh, yeah.
Also, you're going to need a sturdy table because, as I said, this is a heavy printer weighing in at 30 kilograms, and it really throws itself around. So you don't want a weak or wobbly table. Special things to consider are that the linear motors have a strong magnetic force within 2 inches or 5 centimeters, so you want to avoid getting any electronics near them. And anybody with a pacemaker should stay at least 1 meter away from the printer. If you are working on a prototype project and you need some help, I have the answer for you. This brings me to the sponsor of today's video, PCBWay. If you are working on any prototype projects, they can help you when you need a variety of parts. Besides making PCBs, they also offer CNC machining, sheet metal fabrication, injection molding, and lots of different types of 3D printing, including metal printing. You just need to go on their website, upload your design, select the material and quantity you need, and you'll get an instant quote. Then they will manufacture the parts and ship them right to your door. Give them a try, and I think you'll be amazed at what they can do for you. Check out PCBWay using the link below. Now, back to the show. Next, section 3, assembly of the printer. Ooh la la! Let's continue on with our unboxing of this beautiful printer. This is the quick start guide, but really when you open it, it really just has links to the website for Peopoly. They do have a great online instruction manual for unboxing and setting up the printer. And I've printed it out, it's like 84 pages. So let's go ahead and get started. Let's see if I twist it. Just trying to be really careful here. I think I found a magic trick. Okay, let's see what's in the accessory box here. Oh, there's some filament. PLACF. Alright, this is our accessory box. Here we have another hot end. Some Teflon tubing. We'll be mounting our filament holder. Some screws. More of the filament holder details. Some hardware, tools, and a little flush cut trimmer. And inside here, looks like there's the LCD. And sure enough, there it is. It's a nice big screen. So we're going to set this aside. Alright, now it's time to remove these yellow protective covers. Oh wow, these magnets are pulling the cutter towards them. Okay, there's one. And this other one has 3 cable ties. There's 1, 2, 3. Oh, there's another little one. Ah, I didn't see it behind me. Can we see it on the film? Yes, on this camera you can see there's one more that I need to clip over here. I didn't see it because the gantry was hiding it. Okay. Wow, it does move really nice and smooth. Alright, so we have all the protective covers off. We're going to use this one, which is the shorter of the two long ones, to set up the Z-axis. And it wants me to move the print head to the back left corner. There. So now we're going to install the build platform using this spacer now. So you just manually rotate the Z-axis motor. There's one. Two. There's three. Alright, so all four of the Z-axis motors have been set. Okay, so now it's time to lift this build plate. Talk about rotating at 45 degrees. Now I need to get these pins into these little holes here in the four corners. So let's see how that's going to work. Rotate up and then rotate over. It's a little bit awkward. They do recommend you have two people, but it's not always the most practical thing to have two people all the time. But that wasn't bad at all. Beautiful build plate. Wow, thing's really solidly built. The whole thing is really beautifully built. This is a beautiful machine. Now, I haven't turned it on yet, but so far so good. All right, so there's a little toolbox over here. It has our power cord, the all-important screws and springs that we're going to use to attach the build plate, and a trusty little spatula. It's a matter of taking one of these screws that has a little washer and a little sleeve on it, and then our spring, and we're going to go underneath and attach this. Just going to do a loose fit for now. Little pivot joint in there, rotating pivot joint. There we go. I'm going to rotate this so I can get to these. Boy, it seems to be off by a fair amount. That was a little tricky getting the build plate lined up, but I think I've got it. So now I'm just tightening up the screws. Okay, so now we're going to use the two longer set of screws to install the LCD screen. Okay, so where is that little webcam? I saw it earlier. Is that it? Yeah, there it is. Okay, so this is the front of the machine. Here's the webcam. Of course, there's the Magneto logo. Here's our LCD screen. And we're going to mount it right here with the two longer screws. What did I do with them? Here they are. Again, LCD screen, two screws. We're going to mount it to the front. Let's see how this thing does. A clip on. Let's see. Move the cover. Where's our screw locators? Oh, there they are. Okay, now I see. So it goes through here. I'll show you a close-up here in a minute. You know, I just put together a video on all the best tools to use for 3D printing. Why don't I take my own advice and get my screwdrivers? Much better. Okay. LCD is installed. Now, I'm sure we have to connect the cable. Where does that connect? Oh, of course. I'm thinking this has to connect to the LCD screen. Maybe it does, but right now, here's the cables to the LCD screen, so I need to get this thing off. So anyway, this is what I'm referring to. I've got to take this thing off, and the cables are right there. And while I'm over here, I'll just show you what I was doing. This is how the LCD screen is mounted. These are the two screws that I just popped in right here. This one and this one. And there's the little bracket. Okay, so here are the two cables that go into the LCD screen. So we will get this one in here. And this one, whoops, wrong one. This one loops around. USB-C goes right into here. Still not sure what this little puppy is. Is that for the camera? Oh, yes. Maybe we'll get to that in a minute. But it looks like the camera connection, yes, this is here's the cable that needs to connect to the camera. Right now the camera is just sitting there by itself. It looks like I'm going to need to loop this around somehow and get it in there. Now, of all things, they want me to install the filament rack. Alright, so looks like you need to take this top ring off here. Looks like there. So now we have to put the ring back on. Okay, so there we go. Okay, so now we have our plate here that we need to attach our PTFE tubing connector. This is my trusty adjustable wrench for a snug fit. Two pieces of tubing which look like they're approximately the same size. Okay, I finally got the tubing in. I actually had to sand the tubing because it just was not fitting through that fitting. But anyway, we have our 2 centimeters sticking out. Yikes. It's a little awkward here. Okay, what's next? Install Wi-Fi antenna. Okay, so now I'm going to spin this around to the back. By the way, I forgot to put in this last little piece of tubing here. This goes into the head. There's a tiny little clip there that you're supposed to take off, push the tubing in, and then put the clip back in. Time to mount the Wi-Fi antenna. Need to remove it off the foam. There is double-sided tape on the back. Next is section 4, setup. Let's power this thing up. Oh, so far so good. After powering up the printer and seeing that everything looks good on the touchscreen, take a look at the LED lights in the back of the extruder. The left light is the power LED, and that should be red. And the right light is the load cell LED, and that should be green. There are also 2 LED lights and 2 buttons at the bottom of the printer. When the lights are green, that's the normal state. When either one is red, that is an abnormal state. The left LED is the X motor status, and the right LED is the Y motor status. The left button will disable the linear motors if you push it down and hold it for 3 seconds. And the right button will enable the linear motors if you push it down for the same 3 seconds. Now let's look at the touchscreen interface. The left arrow lets you go back to the previous screen, and the little 4 squares icon takes you to the main interface. The little book icon brings you to the macros quick access, and the red circle is the emergency stop button. The main screen shows you the extruder and build plate temperatures. To change temperatures, touch the temperature and a subscreen pops up where you can enter the desired temperature. On the right side of the main screen, you have 5 buttons. Number 1, homing, and that homes the various axes. Number 2 is temperature, and that's a submenu changing and reviewing the various temperatures of the system. The next icon is actions. That has a submenu of all the movements and leveling commands. The configuration icon brings you to a submenu for connecting to the network and bed mesh leveling. And then the last icon is print, which brings you to a submenu for printing your various parts. The first thing you want to do is calibrate the printer. And the first step is to perform the quad gantry level operation. It uses the load cell sensor to check and adjust the 4 corners of the platform to get the optimal leveling. So, go to the homing screen, then click quad gantry level. The build plate will heat up to 50 degrees C, and then the tool head will move to the 4 corners to take measurements and make adjustments. If you get an error message, too many tries, then try the leveling a second time. If you still get the same error message, you will need to contact Peopoly. My one comment is that if the sequence is successful, there isn't a pop-up message letting you know that the cycle is finished or that it's successful. After you finish this step, the next step is bed meshing. Go to the configuration screen, click on bed mesh icon, and then click calibrate. The tool head will take multiple measurements across the entire build plate, and the results will quickly pop on the screen and then they'll disappear. Next, you will need to save the configuration by choosing continue. To connect to your Wi-Fi, click on the configuration tab, then network. Click on the circle in the upper right of the screen and soon the available network should appear. It took me a few tries before my network appeared. Choose your network, then enter your password. You should see the screen that says that you are connected. I also had issues with this step because the printer indicated I was connected, but there wasn't any IP address shown. I tried several times, but I basically gave up until the next day. The following morning, I tried it again, and then I could see my IP address. Per Peopoly's recommendation, the next step is to go to your browser and enter the IP address. But when I did that, I kept getting error messages that I could not connect, even though the printer said I was connected. Then I downloaded the special Magneto X version of Orca Slicer. I went to the Device tab and tried to type in the IP address there, but I got the same error message. I finally had success if I opened up Orca Slicer first, then turned on the Magneto X, and then typed in the IP address in the Orca Slicer. Sometimes I would have to go to the configuration screen of the Magneto X and reconnect, and then it would work. I haven't had these connection issues with the other 3 printers I have here in my workshop, so I really don't know why it's so temperamental. To prepare the camera, remove the camera cover and connect the camera cable to the camera. While you're in the Device tab of the Orca Slicer, you need to modify the Magneto Toolhead config file. Double-click to open up the file, and then on lines 86 and 87, change the minimum temp to -60 and the maximum temp to 300. As of March of 2024, there's a bug with Ink Clipper, so temporarily Peopoly recommends to disable the filament runout sensor. So while you're in the Magneto Toolhead config file, go to the code lines 137 and 40 through 40 and add the number symbol in front of the code line. Then hit Save and Restart button. The Orca Slicer is an open source slicing software that has many features. There is a Peopoly version of Orca Slicer that Peopoly recommends to download that has the Magneto X as one of the printer choices. If you go to the Device tab, you should see the Magneto X control interface, including a live shot of the camera. To load the filament, cut the tip at an angle. Load the filament spool onto the spool holder and thread the filament through the Teflon tubing and into the printer tool head. Preheat the nozzle using the touchscreen temperature screen. For the Peopoly PLA carbon fiber, set the extruder temperature to at least 200 degrees C. Use the touchscreen Actions tab, then click Extrude. Click the amount of millimeters and click the load icon. Continue to click the load button until you see the filament coming out of the nozzle. Next, section 5, making parts. On all the parts, I used the installed 0.4 millimeter diameter medium flow nozzle. For my first part, I had to choose the benchy design that was in the printer files, which took about 28 minutes, using the 0.2 millimeter layer height. Overall, it looks really good. There is some ghosting around the hole in the hull, but I don't see the typical hull line that I normally see where the hull builds up from the deck of the benchy. One improvement I see that is needed is for the tool head to move to a corner away from the finished part instead of being so close to the part when it's done. You can't remove the build plate without possibly hitting your part on the nozzle. Next, I tried these long cylinders with a single wall thickness. It's really hard to see the layer lines. I did get a bit too anxious in removing the cylinder from the build plate, so I broke the bottom off. So I decided to hit the reprint button. However, when the printer started to run, when it was running the purge line, the nozzle began digging into the build plate, so I had to immediately stop the print. So it seemed to have lost its Z-axis position. After that, I would just make sure that I would always rehome my axes before I would go to the next print. Next, I decided to print one of my files. So I loaded this round box design into the Orca slicer. This also used a 0.2 millimeter layer height, and it took about an hour to print. The layer lines look nice, but there is a noticeable layer line where the walls of the box begin from the inside bottom of the box. Also, the inside box bottom is quite rough, and there are some rough spots on the rim of the box, so definitely some tuning is needed. Then I ran this calibration module from Printables at Gearbox 3D using a 0.2 millimeter layer height, and it took about an hour and a half. There was a fair amount of whiskers, but the dimensions were fairly accurate. For instance, this 10 millimeter cylinder measured 9.97 millimeters. And the overhangs turned out quite well, even at 75 degrees. Then I ran this geometric shape using a 0.2 millimeter layer height, and it took about 36 minutes. Overall, it turned out pretty well, but I do need to adjust the pressure advance to improve the edges. Then I changed filaments to the Bamboo Lab Orange PLA, and I ran this Eiffel Tower design from Printables Michael Fanta, using a 0.2 layer height that took about 9.5 hours. The size is about 5 inches wide by 12 inches tall. A number of the supports broke free from the build plate during the printing, so I'm really happy that it still turned out as well as it did. Then I printed out a whole slew of parts for this Bamboo Lab engine kit. I used a variety of colors of Bamboo Lab PLA, and all the parts were printed at a 0.16 millimeter layer height. I had to reprint several parts due to them lifting from the build plate, but overall I was happy with the quality, knowing that I still needed to do some optimizing of the printer settings. Speaking of which, I did decide to eventually run some calibration for the Bamboo Lab PLA. So first I ran a temperature tower with the range of 190 degrees C to 230, and I think the best results were around 215 degrees C. Then for a maximum flow rate, I started at 20 cubic millimeters to 40 cubic millimeters, and then I chose 30 cubic millimeters as a conservative setting. And then for an optimal extrusion ratio calibration for this flow rate pass 1, which will print out 9 samples from a positive 20 to a minus 20, and then I chose the best one and used the calculation to come up with a new flow ratio of 0.931. And then lastly, I did a pressure advance calibration by printing out this tower. And I printed it out from 0 to 0.1 in 0.002 increments. I measured the height at which the corners looked the best. In my case, I chose 25 millimeters. So that adjustment turned out to be 0.05. In my next video, I'll show you how I optimize those printer settings for better quality parts. Next, section 6, the insulation upgrade. In the Made with Layers YouTube channel, Thomas pointed out his concerns with the exposed 220 volt wires under the printer, as well as the underside of the heated platen. Peopoly immediately addressed his concern by designing a retrofit kit for existing printers in the field. Peopoly expedited shipping one of the insulation upgrade kits to me. So now I can show you how I was able to install it on my machine. First thing we want to do is give ourselves about 100 millimeters of a gap between the tool head and the platen so we have some room to work with. I'm going to hit 50 millimeters and we're going to go down. And one more time. Next, we're going to turn the printer off and unplug it to be safe because we're going to be exposing some of the wires underneath the printer. I'm going to use these foam pads to protect the printer. All right, so we're going to remove a couple of these screws here, which are going to be the ones that are going to be holding the insulation. And here's the power coming in. So these are all the 110 volt lines that we're going to be protecting ourselves from accidentally touching. So that's going to just fit over there just like that. Next, we're going to put that silicone pad on. Remove our PEI sheet. Next, we're going to remove this platen by unscrewing 4 screws. So we've removed the 4 screws. All right, next we want to remove the aluminum plate here. And this makes up the majority of the weight of this platen. So if we get this out of the way, it should make it a lot easier. This thing weighs quite a bit. All right, so now this is a little tricky to get this thing flipped over because you have to be careful of the wiring that's attached to this thing. I'm going to move the head off to the left here. That might make it a little easier. All right, and here's our silicone pad. Pressure sensitive adhesive on the back, so you want to get this aligned the first time because it could be a bear to take this thing off to reposition it. So I'm just peeling back a little bit of the release liner. I'm going to rotate it around. I'm going to line it up with this corner here. Actually, with both corners. All right, I'm happy with that. I have this little veneer roller I'm going to use to make good contact here and make sure there aren't any bubbles. And then I'm just going to rotate this over to expose the liner to bring it a little more. Peel a little more back. It's a little tricky just to hold everything properly because I'm trying to prevent the silicone from making contact before I want it to. So I can get the roller in here. It's just a light pressure I'm using. All right, I'm going to peel a little more of the liner. The release liner here is in my way. Now it's ready to get rid of the last of the liner since we're down towards the end here. You definitely are only going to put this on one time because this is some pretty aggressive adhesive, it feels like. You don't want to have to peel this thing off. Now, the tricky part is to flip this thing around again. Being real careful with the wires. Also, just to point out, there are some loose little collars or standoffs that are on all 4 corners here where those screws go in. That's what elevates this platen here. So it'll take a little bit of finagling to get the screws back in. Time to put our aluminum plate back in place. All right, got 2 out of the 4. Pop our PEI plate on. Plug her back in and fire her up. Next, Section 7, Pros and Cons. Overall, this is a well-built, solid 3D printer. The extruded aluminum frame is very rigid, and they used high-quality materials to build it. The closed-loop magnetic linear motors have a lot of potential to offer more consistent, reliable motion in the X and Y directions versus the typical belts and stepper motors. The Magneto X has a large print volume of 400 by 300 millimeters and a maximum print speed of 800 millimeters per second and a maximum acceleration of 33,000 millimeters per second squared. They use the load cell for Z auto leveling, and they have a 1,000-watt heater for the build plate to reach the maximum temperature of 130 degrees quickly. The combination of the maximum hot end of 300 degrees C and the optional enclosure allow a variety of higher temperature materials to be printed. They have designed the printer to be open sourced using Clipper firmware and the Orca slicing software, and they actively support both projects. I think the biggest area for potential improvement is in the software and the firmware to optimize the overall print quality of the parts. Speaking of firmware, as I'm filming this, Peopoly has just announced that they have a major firmware update, so I will be trying to install that this weekend. That's the good news. The bad news is that the instructions require me to open up the electronics panel and remove the TF card from the motherboard. So I wouldn't consider this a very user-friendly process. I don't want to be accused of being a Bamboo Lab fanboy, but with the Bamboo firmware update, I receive a message on my printer screen that a firmware update is available, and I just have to push a button. For $2,000, I was expecting the printer to be a bit more user-friendly for the non-3D printer expert, and maybe that will come with time, which I hope so. I'm also a bit concerned with the repeatability of the Z-axis motion of the 4 stepper motors, because I have had some issues with the nozzle scraping the build plate. Overall, I'm glad I took the chance of buying this Magneto X, and I am looking forward to working with Peopoly to continuously upgrade and improve the printer. In my next video, I will install the enclosure and run some higher temperature materials to test it out. Tell me in the comments below what tests you would like me to perform with the printer and what materials you'd like me to run. If you found this video useful, I would really appreciate it if you would consider clicking the like button and consider also subscribing to my channel for future content. Thanks for watching. Bye!